Hey, hi everyone. Good evening. Welcome back to the channel 360DigiTMG. We are proud to announce another project. The project is about predicting the rake optimization based on the sales figures from a fertilizer company. This is predominantly into the sale supply chain and of course sales forecasting. And congratulations team to pull this off. And I would want Prakriti, please take it over to present the case. Congratulations.
Thanks. Yeah, thanks, Sharad. Good evening, everybody. So today we'll be presenting on the sales prediction for Rake optimization. I would like to thank Sharad sir, Jameel, Nitin Mishra sir, as well as Samrat for providing this opportunity to us. So can you please move on to next slide? Yeah. So we were able to pull off this project with the help of and with the effort of our team. So these are the team members: Almelu, Shilpa Rani, Prakriti, myself, Ramu, Pavan, Nikki Sharma, Deepthi Sarikonda, Girish, and Shiva, Sayed, Nirmal, Piyush, Rajkumar, Biswant, and Deepthi Reddy. So from help of our team, we were able to pull off this project. So speaking about the sales prediction with respect to the rake management system, we followed the CRISP-DM techniques, wherein the goals and objectives and importing the data, performing EDA and model building, deployment, all of these are the stages that we followed. Can you just move on to the next slide? Yeah. So in this project, which is the sales prediction, the main goal of the project is to predict the sales of the fertilizers on a monthly basis. Here, the data collection, basically we took the monthly basis because we didn't have the data in terms of the daily basis. So we had to predict the sales of the fertilizer on the monthly basis on different states, which was for our client who is a fertilizer company, in order to plan the production and the railway rake management accordingly for our client. And speaking about the goals, the objective was to optimize the production of the fertilizers and also the usage of the railway rakes, which was the medium for them to transport their fertilizers from one state to the other, and taking that information, predicting the sales of that transportation through rake or through train, in fact, monthly basis. Can you just move on to the next slide? Yeah. So coming to the next step, which is the scopes and assumptions that we have made when it comes to our project. So the data collection, which was a tedious one, wherein the data needs to be collected. So the website or the medium through which we relied on for data collection is MFMS website, which is basically the fertilizer website, the government fertilizer website that is available for us, through which the transport is basically done through railway. The fertilizer transport is done to railway. So we took the sales for our client CFCL, Chambal Fertilizers, from Jan to December 2020 data. And we had to take that data, collect that data manually and read it through the Python, wherein we implemented the same sales prediction in Python and built a machine learning model on them. So the website for that MFMS website would be the one that is pointed out in the presentation. Next, after that, after the data collection and importing of the data cleansing and regarding to whatever the exploited data analysis that is required has been done, and the data transformation has been done for a set of the variables in our data. then necessary feature selection, and also the application of different machine learning algorithms for analyzing and predicting the sales for the next future years. So, and we had to present the predictive analysis results for the same. The assumptions that we have taken in this project is the data that we procured is historical data from the MFMS website that I just talked about in the previous scope of a project. So the data that we have collected is from sales from January to December in 2020 for different set of categories. Our client, which is CFCL, different products that we were able to collect is the urea, MOP, DAP, NPKs, compost, and different set of states like Bihar, Chandigarh, Haryana, Jammu, Kashmir. So our client basically was into the north part of India. So these are all the states that had transported the fertilizers through the railway system. And this is the architecture, as I told you, the CRISP-DM architecture that we follow: understanding the business problem, then understanding our data, preparing our data, by performing EDA and transforming the data and performing feature selection, then modeling the data, evaluating, and deployment using Flask, which we'll see in the further set of slides. Can you please move on this? So this is our architecture. The import of the data is from MIS report system, MFMS report system, or the website URL that I provided. Then set of exploratory data analysis and model building. The model that we relied on is ANN model with 5 hidden layers and different set of respective neurons being added in those hidden layers. All of this built under a Python environment. And then after building and predicting the sales, this machine learning algorithm or the ANN model is imported and being deployed in the Flask method, wherein the input that we provide in that web page is month, fertilizer, and state. The outcome or the output is basically the sales in metric tons. Next slide. Yes. So this is the structure, as I told you. First is data collection, then respective data pre-processing is done, then the machine learning models are built on the same cleansed data, and prediction of the data on the new test data or the new data, and deployment in Flask. Yeah, next slide. Right. So we imported the data. As you can see, this is the website, MFMS website, the government website that we relied on for our client CFCL, state-wise from Jan to December 2020. As you can see in the picture that is incorporated here, we're selecting the company and the date for different set of products or the fertilizers that they basically transport, right? And the products, sub-products that are related to that as well. And the respective state-wise sales is provided from the same website. The same way we exported, or imported the data for all date from Jan to December for all the months for different set of products or categories that our client is into. Next. And after importing the data, you can see the data is in this Excel format. Yes, next slide. And by importing that data to our Python editor that we are taking, which is our spider here, the data looks the same way. I would like to give this to Shilpa. Shilpa, you can take over. Yeah.
Hi, everyone. Prakriti had explained how the import of fertilizers has been done from CFCL website. And then from CFCL, it is transporting its fertilizers to 11 states in India. It is having different product groups. The product groups are urea, NSPK, DAP, MOP, etc. So now I will explain you how we are predicting the sales, future sales for the CFCL, and based on the prediction of future sales, how we are going to optimize the rakes. Rakes means transporting of fertilizers using railway transport from CFCL, which is in Rajasthan, to different states, 11 states. So this is the way we are importing the data from MFMS website. This is the MFMS website, reports.dbtfertnic.in. And we have taken the sales for Jan to December 2020. And we have extracted this data to Excel sheet. After extracting this data to Excel sheet, we have imported this data to Python. And how the data looks in Python is this way. This is the command we used. This is the syntax we used for importing dataset to Python. And after importing dataset to Python, it is having 314. Our dataset is having 314 rows and 4 columns. Now we had preprocessed the data. By changing few of the column names and converting actually the months are in timestamp format. So we are changing the timestamp format to month format. And we are checking if there are any null values in the dataset. So to reduce the sparsity. And after checking the null values, if there are any null values, we are replacing the null values with zeros in data preprocessing steps. And after that, we created dummy variables for month column and fertilizer column and state column. And this is how the data looks after preprocessing using all these commands. Now the data is having all the values in between 0 and 1 except the output column sales in metric tons. So we are normalizing the data using the function normalized function. This is a normalized function. We use a normalized function and normalized the output variable sales metric tons. After doing normalization, this is how the sales data looks. Now all the data is in between 0 to 1. After pre-processing and making all the values lying in between 0 to 1, we have splitted the data into train and test data, train data, test data by using train test split function. And we had created the model, we created the ANN model, artificial neural network model. We have defined the artificial neural network function, and we did not given any parameters here. Here we have taken different hidden units for the above defined function with the different hidden units 27, 20, 20, 20, 15, 10, 1. And we have fit the model using these hyperparameters with epochs of 100 and batch size of 32. After fitting the model, we got the test and train accuracy of 96.7% and test accuracy of 81.43. Now we saved the model. After saving the model, we created input data for prediction. This is a block of code for creating the input list, creating to predict the future sales. And we had given for month September 1 value and state Bihar 1 and fertilizer urea 1. We have highlighted these. And after giving this value, we got the list of values this way. And we are giving this input to the above model, saved model, to predict the future sales. So now we are getting the output by predicting using the saved model and passing this list of values. And this is the output we got. After getting output, we again rounded up that value with 2 decimals. And this is how we got the output as this 15,568.88 metric tons. Now deployment using Flask. This will be explained by Alimelu.
Thanks, Shilpa. Hi, everyone. So that the client will be able to use the model that we have created, we have deployed the model using a Flask application. And Shilpa, can you go to the next slide? Yeah. So in the Flask, this is how we have created the web page for the Flask application. So we have the 3 inputs, as Shilpa has already explained. There are 3 inputs: the month, the fertilizer, and the state. So these are drop downs, and we can select whichever drop down whichever value we want. And when we do submit, it'll go back to the model, and it will run a prediction on the model, and we get this value as the output. So Shilpa, you can explain about the.
Yeah. After giving these inputs, the month, fertilizer, and state, we will get the predicted value of sales. So based on these sales, we can use the Rake's optimum way. Like if we know the sales, so we can go to this particular website, fys.indianrailgovernment.in, and there we can check for availability of rakes. Like if we know that we need to transport 24,140.99 metric tons for the Jan month of 2021, as we have predicted for 2021 Jan month. So we'll go and check in this website for Jan 2021 is how many rakes are available to that particular state. Like this is for Bihar, and this is for urea. So we'll go to this particular website and we will check for Bihar state for Jan 2021 how many rakes are available, and at what particular dates rakes are available, and how many wagons are available, and how much cost it going to incur. And we'll check all those, and based on the cost and based on the availability and based on everything, we will book the rakes and we will send the goods to that particular state, to all the dealers in that particular state without any delay, so that the dealer gets the product in time without any delay. So we can optimally utilize the rakes without any delay, or also the cost, and also incurring very less cost comparing to comparing to costs which are incurring in high demand. Thank you. And this is about the project we had done. Fertilizers to different states using rakes. And if you have any queries, you can ask so that we will answer them. Till then, I will show you the code, how it will run and how it runs on backend and how it runs on front end. I will show it to you so that if you have any questions, you can ask us, we will answer them. We are importing all the libraries, whatever needed for NN model and for predicting the sales.
Shilpa, I'll show the Flask application in the meantime.
Yeah, please show it. Till then, I'll check out. I'm
Yeah.
having some issue.
So yeah, as I was talking, this is the Flask application. And so basically we have running it on ngrok so that anybody from the internet can actually access if we do it on ngrok. This so here we have given this drop down for the months, and these are the different fertilizers: urea, DAP, MOP, NPKs, and compost. And these are the states where the client is transporting the fertilizers to. So we can suppose we give these three. So we are getting this as the output, 24140.99 metric tons. Now, if I change this to some other fertilizer and Chhattisgarh, suppose, and some other month too. So it's lesser value. So according to the data that we got, urea is actually the one which has lot of production as well as even import from outside, and even the people also are using that fertilizer more. So compared to the comparatively DAP, MOP, NPKs, and compost, the amount that is transported is very less. So accordingly, the clients can come up with their rake optimization plans based on these predictions that we make. So let us try another, suppose for December, and I'm giving compost and Rajasthan. So it's giving the value as 3,884.42 metric tons. So this is how we can deploy. So what happens is actually it will go to the model, and all these we have created dummy variables for the month. So it will take that many, it will create the dummy variables with the input values given, and then run it into the model, and the model gives this prediction. So that is how it's working. So yeah, that is about the Flask application deployment and how the client can use it. Any questions, anybody? Yeah, there's a question. They want to see the input features. Do you mean in the code or from Mr. Naveen? These are the input features, Mr. Naveen. So we have 3 input features for this model: month, the fertilizer, and the state. So these all the 12 months are there, and these are the various fertilizers which are manufactured or imported by the client, and these are the various states to which it is getting transported. So these are the 3 input features. I hope that answers your question. Yeah, there's another question from Mr. Naveen, and he's asking why didn't we use time series here? So the thing is, we didn't exactly get the data in a time series format. The data which we got is for month-wise. So it's month-wise, and it's not necessarily that for every month it is there for all the states and for all the fertilizers. So it was not exactly a time series data because it is multivariate data. So we can't use normal time series forecasting because it is multivariate, and it is not exactly like for every month you have the values for all the states. Or if we had to do time series, then we would have to take it for each state, for each fertilizer, and then build a model. So that is actually not will not serve the purpose. So that is why we couldn't go in for a time series model, forecasting model, because the data was not in that format. Hope that answers your question.
Mallikarjun also asking the same question. Can we use forecasting model rather than artificial neural network? Yeah, Mallikarjun. For forecasting models, we have the time series data should be in sequential manner. The data should be in sequential manner. Here, we data is not having in sequential manner, so we are not using forecasting. So we are using artificial neural network. I will show you the data so that you will understand easily. This is the data we have. Sales data. So if you see here.
Shilpa, your screen is not shared.
Okay. Yeah, I'm showing it now. So here, if you see the data here data is not in sequential manner. See, Jan, all the months are Jan. And next the data is in Feb. So the data is not in sequential manner. So in order to use forecasting method, the data must be in sequential manner. The time series data should be in sequential manner. So we can't use forecasting method here. So we have gone through ANN method to forecast the sales. Hope you got the answer, Mallikarjun. Yeah, Naveen, we had taken only for one company, that is CFCL, manufacturing fertilizer, different kind of fertilizers to different places. Like different places means 11 states it is manufacturing in India. So this is the one company manufacturing fertilizers to different states. So we are also predicting sales only for the one company, that is CFCL. Um, Hi Bhaskar. Yeah, train accuracy is 96 and test accuracy 81. We had taken only data for 317 rows. So if we had included more rows for the by considering the previous years also, like we had considered only 2020 data to predict the sales for 2021. If we had considered the previous years also, like 2019 and 2018, there will be more rows of data and more information will be there, so that there will be no overfitting and we'll get some the accuracy as we need by taking more data.
Actually, the site from which we were taking data, it had limitations the way we are extracting data. So it was allowing us to extract only for on a monthly basis the data. So we were able to extract only for 2020. If we were because that itself it took we had to extract it like around 40 times to get this much of data. So if we had more data, then we could have got a better accurate, I mean, a right foot model. And this is with this data we took it on our own to show it to the client, because and client couldn't provide us more data also.
Yeah, Mallikarjun, you asked us to run the Flask code. So I once we'll show it to you.
Yeah, just give me a minute. Yeah, so this is the Flask application, the web application. As you can see, we have the 3 input features: month, fertilizer, and state. So if I give for this June month, and suppose I'm giving NPKS, and I give Madhya Pradesh, so it's giving 3398.17. So mostly we get for urea, we get high values like so this is for urea. So urea is actually the one which is manufactured the most and transported also the most. So other fertilizers are like used very, very less. So this is how the Flask application works.
Yeah, Almelu, give me a second. Please be on that screen. Yeah, Sita Ramaro, yeah, that is possible. We had built the model only for the particular state. So if we select the state Bihar, so we can predict sales only for that particular state. If we selected another state like Chhattisgarh or Punjab or some other state, we can predict only sales for that particular state like Chhattisgarh or Punjab or whatever we have chosen. So that is possible. Hope you all got your answers. So thank you everyone for joining the session and giving your valuable time. We see you soon. Thank you.